Hello, welcome to my channel Chemical Chemistry classes. Today we are going to discuss fission of covalent bonds, right? So before starting this, I will discuss with you the fundamental concepts of organic reaction mechanism. As you all know, in an organic reaction, the organic molecule reacts with an appropriate attacking reagents and leads to the formation of one or more intermediate, and one of the intermediate and other is a product, that is a final product. So we can say a journal reaction where is a organic molecule, or we can say organic molecule as a substrate. When reagent react over it, attacking reagent, then an intermediate is formed and that leads to the product, right? Intermediate gives some byproduct, right? So this is substrate in that reaction which supplies a carbon to a new bond in the other reactant is called the reagent, right? So if, as we understand, in a reaction one molecule is usually called the substrate, right? We have to call one molecule as a substrate, the main molecule that is undergoing change, and the other is reactant, and is the other reactant, or we call it as a reagent. That means that is the attacking or reacting species. If both reactants contribute carbon atoms to form carbon-carbon bond, and that reaction when both reactants contribute carbon atom to form a new carbon-carbon bond, the reaction is called the condensation reaction, right? So during that process, the covalent bond either between two carbon atom or between carbon and other atom are broken and new bonds are formed. So the reaction does not occur in a single step. It takes the sequence of elementary steps, and each step involves bond breaking and bond formation that leads to form some intermediate species such as carbocation, carbanion, or free radical. We will discuss all this in detail here. And to this detailed step-by-step description of how a reaction proceeds from reactants to product, so the intermediate is called reaction mechanism. Reaction mechanism is just like a step-by-step description of how a reactant is converted into product. This is all about their history, right? So this reaction mechanism helps us to understand which bonds are broken or formed, and which intermediates are produced, and how electrons move during the reaction. This is all about the reaction mechanism, right? So next our topic is a fission of a covalent bond. As you know, covalent bond can be cleaved either by heterolytic cleavage or by homolytic cleavage, right? So there's a two cleavage how covalent bond can cleaved, right? So in heterolytic cleavage, what happen in heterolytic cleavage, the bond breaks in such a fashion that the shared pair of electrons remains with one of the fragments in heterolytic. So after heterolysis, one atom has a complete electronic structure and a positive charge, and the other has a valence octet. So this is through one example of a bromomethane. I will explain you. This is the example of bromomethane. For like this is formed, this bond is shared, so this becomes like this. We are negatives, right? So in heterolytic cleavage, what happened? The bond splits unevenly. One atom takes both electrons from the bond and other gets none. So this process forms ion, a cation or anion. This forms an anion, right? A cation and anion, right? So the heterolytic fission generally occurs in the polar solvents, right? So example, this is like of bromomethane. And I will give you another example of hydrogen chloride. Like this is hydrogen chloride. When this process undergo heterolytic fission, this become H positive and Cl negative. So chlorine atom takes both electrons and become chloride ion, right? So a species having a carbon atom possessing 6 of carbon and a positive charge, that is called the carbon cation, or we call carbonium ion, right? So carbocations are classified as primary, secondary and tertiary depending on whether 1, 2 or 3 carbons are directly attached to the positively charged carbon. Right, so some examples as we discussed, there is ethyl cation, or also we call that ethyl cation like primary carbocation. Isopropyl cation, as you say, this is a secondary carbocation, and third butyl cation, this is the tertiary carbocation. I will show you with this. First is primary, secondary and tertiary. So first is ethyl cation. Next is isopropyl cation. This is just CH. This is what? This is third butyl cation. This is primary, secondary and tertiary, right? So in homolytic cleavage, what happened? In homolytic cleavage, the bond splits evenly and each atom takes away one electron from the bonded pair, right? So this produced two neutral species, that is called free radical, each with unpaired electron. Homolytic fission occurs in non-polar and solvent with heat or UV light. So in homolytic cleavage, when one of the electrons of the shared pair in a covalent bond goes with each of the bonded atoms, thus in homolytic cleavage the movement of single electron takes place, like instead of a electron pair. So single electron movement can be shown in homolytic by fish hook, like this, right? Fish hook curved arrow. Such cleavage result in the formation of a neutral species which contains an unpaired electrons. These species that are called the free radical. So a homolytic cleavage can be shown like this. Right. So heat or light are needed, and this is the fish hook, like this. So these are the alkyl free radicals. So alkyl radicals that are classified as a primary, secondary and tertiary. Alkyl radical stability increases from primary to secondary, right? So this is the methyl free radical, and this is ethyl. This is isopropyl, and this is third butyl, right? So organic reactions which proceed by homolytic fissions are called the free radical or homopolar or non-polar reaction, right? So this is about the homolytic and heterolytic cleavage, right? So heterolytic cleavage is, as we revise all this, heterolytic cleavage, in this the bond splits unevenly. Bond splits unevenly, and one atom takes both the electrons from the bond and it gets none, and then these process forms ion or cation, that is some positive charge. This process forms some ions, right? So the heterolytic fission generally occurs in polar covalents. They occur in polar covalents, and the example we have discussed, that is of HCl. In homolytic, what happen? In homolytic cleavage, the bond splits evenly and each atom takes away one electron from the bonded pair, and this produces two electron spaces, and that's called free radical, each with unpaired electron. Homolytic fission occurs in non-polar covalent with heat or UV light. So this is about homolytic and heterolytic. Or I will give you one more example for the homolytic, that is chlorine gas, like this. Chlorine gas is hit by UV light. So what happened when chlorine gas is hit by UV light? Some free radicals are formed, right? So each chlorine atom gets one electron, forming two chlorine radicals, right? So next is substrate and reagent. Before discussing substrate and reagent, we will discuss carbon cation and carbon anion. As you know, carbocation is a carbon atom with a positive charge, and it has lost an electron. That forms only 3 bonds and has a empty orbital. So its symmetry is trigonal planar and 120 degree. So in carbocation act as an electrophile. Why? Because they seek electrons and can be attacked by nucleophile also. But in carbon anion, what happened? In carbon anion is a carbon atom with a negative charge because it has gained an extra electron and has 3 bonds to other atom and 1 lone pair, which makes the geometry like typical trigonal pyramidal, not flat, and carbon anion act as a nucleophile. Substrate and reagent. As you know, ions are generally not formed in the reactions of organic compound. Like molecule as such participate in the reaction. It is convenient to name one reagent and and other as a substrate and other as a reagent, like this, right? So think of the substrate like the main character of a story, and it is the molecule that's going to be changed in the reaction. And reagent is the what? Reagent is like the supporting actor, right? They have to support the reaction that comes into to help and make that change happen. Basically, substrate is what you start with, and the reagent is what you add. Reagent is going to add to get the reaction going, right? So I will take one example like this. In this reaction, we are adding reagent with substrate and get our desired product, like this. This is substrate and this is what? This is reagent, and we get our desired product, right? So when carbon-carbon bond is formed, the choice of naming the reactant as substrate and reagent is arbitrary and depends upon the molecule under observation, right? So this is about the reagent and substrate. Like substrate is what? Substrate is what you are starting with, and reagent is which is going to add in a reaction. Like next is nucleophiles, right? Nucleophiles, we can write it like this also, right? So nucleo, this means what? This means nucleus, right? And positive center, and phile means loving. So nucleophiles means nucleus loving. This is what? This is nucleus loving. This is we get from their name, nucleophile. What it does? It donates a pair of electrons to the pair of electrons to form a bond usually carry negative charge. As you write nucleus, this is carry negative charge and it has a lone pair. That means reagent is going to attack a reactive site of the substrate, and the reactive site may be electron deficient portion of the molecule. For example, an atom with incomplete electron shell or the positive end of the dipole in the molecule. If the attacking species, the species which is going to attack is electron rich, it attacks these sites. If attacking species is what? That is, they are electron deficient. So what happens? So the reactive site for it is the part of the substrate molecule which can supply electrons. So a reagent that brings an electron pair to the reactive site is called nucleophile, or we call nucleophilic, and a reagent that takes away an electron pair from the reactive site is called electrophile, and what in easy word we said electron seeking, and the reaction is called electrophilic, right? So what happens when an organic reaction nucleophile attacks an electrophile? As we understand, nucleophile is what? Nucleophile is that with their loving nucleus, right? So with their loving nucleus, and they bring an electron pair to the reactive site, right? What do you mean by electrophile? Electron means what? That is electron. Okay, electron. Phile means loving. So an electrophile is electron loving, and what it does, it accepts a pair of electrons to form a bond, and they usually carry some positive charge. We write electrophile as like this and nucleophile like this, right? So electrophiles, electron loving, nucleophiles, nucleus loving. So they carry positive charge, they carry negative charge. Like, as in a reaction, we all know nucleophile is going to attack an electrophile. Why? Because they are carrying opposite charge. So what happened? Opposite charge attract each other. So when during a polar organic reaction, what happened? A nucleophile attacks an electrophile. In this nucleophile, they are going to attack an electrophile center of the substrate, which is that specific atom of the part of the substrate which is electron deficient. Similarly, electrophile attack at nucleophile center, which is the electron rich center of the substrate. Thus the electrophile receive electron pair from the interaction, right? So simply a curved arrow notation is used to show the movement like this. Curved arrow used for the arrow rotation for the movement of electrons from nucleophiles to electrophiles. Some examples of electrophiles are nucleophile are hydroxide ion, ammonia, chloride, and water. They are the examples of nucleophile. Electrophiles examples are proton, we can write it like this, nitronium ion. You can see they all having a positive charge because they all are electrophile, and aluminium chloride. These are what? This is electrophile and nucleophile. Electrophile is what? That is going to love the nucleus and it donates a pair of electrons. It carries the negative charge. Whereas electrophile means electron loving. It accepts a pair of electrons and they usually carry positive charge or they are electron deficient. Electron movement. In organic chemistry, electrons move around to form or break new bonds, and these movements are shown by some arrows, some fish arrows, some curved arrow, different types of arrow, right? So the movement of electron in organic reaction that can be shown by curved arrow notation that shows how changes in bonding occur due to the electronic distribution during the reaction. To show the change in position of pair of electron, curved arrow notations are used like this. I can show you. This is curved arrow. Right. So this is the pi bond adjacent bond position displacement is going to happen. What happen in fission arrow type of arrow is like this, and like this, and they form CH3 plus this. This is the electron displacement also occurs. This is the electron movement, and I'm talking about electron displacement. What happen in electron displacement? Electron displacement that affects the covalent bond, right? So organic chemistry, sometimes electrons in a bond shifts around a little bit, and this shifting happens because of the influence of nearby atoms or groups, or sometimes because a new reagent is coming in contact. So in electron displacement in organic molecule, that takes place in ground state, that is under the influence of atoms or adjacent atom, as we discussed. The electron displacement due to the influence of atom or substitute group present in the molecule cause permanent polarizations of the bond, and this permanent polarization of the bond, inductive effect and resonance effect are their examples. Like, so temporary electron displacement effects are seen in a molecule when a reagent approaches to attack it. This type of electron displacement, they are called the electromeric effect or polarizability effect. Like, so permanent polarization, that is caused by inductive. Permanent polarization is caused by inductive effect and resonance effect. And temporary electron displacement is occurred by electromeric effect. We will discuss all this effect in detail. First is what? First is inductive effect. Inductive effect, that is we can think of inductive effect as a gentle tug of war on the electrons in a bond. How it works: when you have an atom or a groups that either more electronegative or less electronegative, it will pull or push the electron bit, and this results in slight polarization, meaning one side of the bond gets a bit more. This is a two side, no? One side, what we get, one side of the bond gets a bit more electron rich and other bit of more electron poor. So when a covalent bond is formed between atoms of different electronegativity, then electron density is more towards the more electron negative atom of the bond, like this. Like this. So bond polarity leads to various electronic effect in organic chemistry. Like, let us consider this. This is a chloroethane, in which this CCl bond is a polar covalent bond. It is polarized in such a way that the carbon 1, this is carbon 1 and this is carbon 2. So carbon 1 gains more positively charged, and the chlorine some negative charge. The fraction electronic charges on the two atoms in a polar covalent bond, they are denoted by delta. You can write here like this: delta negative, delta positive, and this is delta delta, like this. So the fractional electronic changes on the two atoms in a polar covalent bond are denoted by this symbol, and the shift of electron density is shown by arrow, that is towards the more electronegative atom. Okay. In turn, carbon 1, this carbon 1, which has developed a partial positive charge, draws some electron density towards it from their adjacent this CC bond. So we get double delta. The option carbon 2 symbolizes relatively smaller positive charge as compared to the Cl1. this atom, which is very close to Cl, get more polarized as compared to this because of the distance, right? So this CCl bond, even in this CCl bond, this is more polarized, so electron cloud is going to shift towards this, right, because of the electronegativity. So polarization of sigma bond caused by polarization of adjacent sigma bond, that is referred to as the inductive effect. This effect is passed on different bonds, but as the effect decrease rapidly as the numbers of atoms are going to increase. So this is all about this. So there are some electron withdrawing and electron donating group. Electron withdrawing or electron donating group. Electron withdrawing group and electron donating group relate to hydrogen, halogens and many other groups like nitro, cyano, carboxylic, ester. They are electron withdrawing. And alkyl groups, they are like methyl and ethyl, they are considered as electron donating group. Inductive effect is further divided into plus and negative, plus I effect and minus I effect. We will discuss in our next video.